Today we're going to be studying mathematics.
And emerges from the second mirror.
These words sound
Be your teacher for today.
Congratulations and welcome to the last lesson of the third module for the upper primary classes of MSI EduTech Online Home Lesson. I hope you are faring well and you're getting ready for the examination at the end of this module. Okay, today we'll be talking about the structure of the earth. The structure of the earth. The structure of the earth is spherical. Spherical. Now, like a ball, like a full moon, a table tennis ball are spherical objects. So, what I have here is a sphere. A sphere. So we could represent the structure of the earth, the world in which we live in, on a globe. The map of the world could be represented on a globe. Alright? Now I want to talk about the center of the sphere. The center of the sphere. If we are able to cut the sphere into two equal parts, what do we have? We have an hemisphere. Hemisphere. Okay? This is a sphere, and this is an hemisphere. Hemisphere. Now, the center of an hemisphere, the flat surface of this hemisphere, it's like a circle, rounded. That is the flat surface of a solid hemisphere, and it has a center. Just like when you have an orange and you cut it into two, you have the solid end as a circle. So this flat, there will be a center. This center will still be the center of the hemisphere. The center of the hemisphere. Now, the center of the hemisphere, a line drawn from the center of the hemisphere to any point on the sphere would give us a slant, a radius, which we call r, radius r. So the radius of this we represent as r. So if we need to calculate the volume of a sphere, we want to try to calculate the volume of a sphere. So the volume of a sphere will be given as 4/3 pi r cube. So the volume of a sphere is 4/3 pi r cube, where pi is a constant, 22/7 or 3.14, and r is the radius of the sphere. We have an example here. Calculate the volume of a sphere of radius 7/2 centimeter. 7/2 centimeter. Take pi as 22/7. So what do? Volume of a sphere is 4/3 pi r cube. We have pi as 22/7 and we have r as 7/2 centimeter. So the volume becomes 4/3 times pi 22/7 times r cube. R here is 7/2 times 7/2 times 7/2. R cube. R cube. All right, and we have centimeter. Okay, so what do we do here? 4 over 3 times 22 over 7 times 7 over 2 times 7 over 2 times 7 over 2. All right, 7 crosses out 7. Okay, 2 year 1 and year 2. 2 year 1 and year 1. So we are left with this. We are left with 1 over 3 times 22 over 1 times 7 over 1 times 7 over 2. So this 3 times 1 is 3 times 1 3 times 2 6. So this is over 6. Then we have 22 times 7 times 7. 7 times 7 is 49. So we have 22 times 49. All right, 22 times 49. Okay. 9 times 2 is 18, right? 18, lift 1. 9 times 2, 18. Plus 1, 19. 4 times 2, 8. 4 times 2, 8. All right, we add up 8. 9 plus 8, 17, right? 7 and lift 1. 1 plus 1, 2. Plus 8, 10. So we have 1078 over 6. Look at what we've done here. 9 times 2, 18. We lifted 1. 9 times 2, 18 plus the 1, 19. 4 times 2, 8. 4 times 2, 8, and we added up 8, 7, 17. Lift 1. So 1 plus 1, 2. Plus 8, 10. So we have 1078 divided by 6. 1078 divided by 6. How many 6 can we find in 1? None. How many 6 can we find in 10? 1. So we have 1 here. 6 times 1 is 6. 10 minus 6 is 4. Bring down the 7. We have 47. How many 6 can we find in 47? That's 7. 6 times 7 is 42. So we write 7 here. 42. Subtract. 47 minus 42 is 5. Bring down 8. Okay, we have 58. How many 6 can we find in 58? That would be 9. 9. Okay, 6 times 9 is 54. Subtract. We have 4. Now there is no other number to bring down. So, and 6, we cannot get 6 in 4. So what we do is add up points here and then add 0 here. How many 6 can we get in 40? How many 6 can we get in 46? Okay, 6 times 6 is 36. How many 6 can we get in 46? 6 times 6 is 36. Okay, subtract. We have 4. Add another 0. We keep having 6. So we could approximate to have 179.67 centimeter cube. Centimeter cube. All right. So our answer, the volume of this sphere would be 179.67 centimeter cube. I hope that is clear. All right, let's take another example. Calculate the volume of a solid hemisphere of radius 5 centimeter. Hemisphere. Hemisphere, we recall, is the half of a sphere. So, volume of a sphere is 4 over 3 pi r cube. But we are looking for an hemisphere, which is half of a sphere. So volume of a hemisphere would be half times 4/3 pi r cube. All right, pi was given as 22/7 and r is 5 centimeter. So the volume of the hemisphere would be 1/2 times 4/3 times 22/7 times 5 times 5 times 5. All right, is there any number we could use to reduce this? Okay, 1/2 times 4/3 times 22/7 times 5 times 5 times 5. All right, 2 we divide 2 once and 2 here 2. Okay, which other number could divide this? All right, none. So we need to multiply directly. 2 times 2 is 44. So we have 44 times 5 is 25, and 25 times 5 is 125. So we have 44 times 125 divided by 3 times 7 is 21. 21. All right, so we need to multiply these. 4 times 4 is 20, write 0, lift 2. 4 times 2 is 8, plus 2, 10, write 0, lift 1. 4 times 1 is 4, plus 1, 5. 4 times 5 is 20, write 0 and lift 2. 4 times 2 is 8, plus 2, 10, write 0 and lift 1. 4 times 1 is 4, plus 1, 5. Then add up, we have 0, 0, 5, 5. So we are left here with 5,500 divided by 21. 5,500 divided by 21. 5,500 divided by 21. How many 21 can we find in 5? None. How many 25 can we find in 55? 2. All right. 21 times 2 is 42. Subtract this. 5 minus 2 is 3. And 5 minus 4 is 1. All right. How many 21 can we find in 13? None. So bring down the 0. How many 21 can we find in 130? 6. 21 times 6. 6 times 1, 6. 6 times 2, 12. So we have 126. When we subtract this, we are left with 4. All right. Bring down the 0. Okay. How many 21 can we find in 41? 21 times 1 is 21. Subtract this. 10 minus 1 is 9, and 3 minus 2 is 1. We are left with 19. All right. How many 21 can we find in 19? None. So a point here, and I had 0 here. So I have, how many 21 can I find in 190? Okay, let's try 9. 21 times 9. 9 times 1, 9. 9 times 2, 18. So 9 here, and we have 189. All right. 190 minus 189 is 1. All right. Okay. So how many 21 can I find in 1? None. Add 0. How many 21 can I find in 10? None. So this 0. Okay. How many 21 can I find? I had 0 here. How many 21 can I find in 100? 4. Let's approximate this to 261.9 centimeter cube. So our answer here becomes 261.9 centimeter cube. So that's our answer. I hope that is clear. All right. Okay, let's talk about a circle. A circle, the properties of a circle. Remember we said the flat surface of a solid hemisphere is a circle. So let's talk about the circle. All right, this is a circle. Now, a circle has a midpoint, a center. Okay, let's assume this is the center of our circle. Now, any point from any distance from this center to any point of this is given as radius r. This is radius. Now, the entire length, this entire length from this point down here becomes the diameter. All right, that means that the radius is half of the diameter. I could also say radius is diameter over 2. Do you get that? The diameter is the entire length across the center. Now, the diameter would also be 2r. So we are looking at the relationship between the radius and diameter. What's the relationship between the radius and the diameter? So the radius is half of the diameter. Now, let's also look at the circle. The circle has many lines of symmetry. That means you could divide this circle into, in fact, infinite lines of symmetry. Various lines of symmetry. Once it's able to cross through this midpoint, this could be a line of symmetry. This could be another line of symmetry. This is a line of symmetry. You could have it all around. So we call it infinite lines of symmetry. All right. Let's talk about the diameter, the circumference. The circumference of this circle. The circumference of the circle is like the perimeter. The perimeter. That means the distance round the circle. If you get a rope, perhaps a thread, and then take the distance round this circle, you get the circumference. Let's call the circumference C. Let's call the circumference C. We already know the diameter. The diameter is a line across the mid of the circle. So let's call that diameter D. Diameter D. Now it has been discovered, and you could try this on your own. Get a perfect circle, get a rope or a thread, and measure around the entire surface, the circumference of that circle. Place it on the ruler to get the measurements. Then measure the diameter of the circle. You will find out that the circumference divided by the diameter would give you a constant. For any perfect circle, the circumference divided by the diameter will give you a constant. Is a constant which we name pi. A constant pi. So we've seen the relationship here. So we could say, since we have C over D to give us pi, we could say now C is equals to pi D. So we can see the relationship between circumference C and diameter. The relationship between circumference and pi D. So circumference is equals to pi D. Pi will be circumference divided by D. All right, let's take an example. All right, here's the question. Find the circumference of a circle with diameter 10.5 centimeter. Take pi as 3.14. Remember we said pi is a constant, which could be 22 over 7 or 3.14. All right, this is a circle. This is the diameter, 10.5 centimeter, and we want to find the circumference. Remember what we did? Circumference is equals to pi D. Pi here is 3.14 and D is 10.5. So circumference here becomes 3.14 times 10.5 centimeter. 3.14 times 10.5. 3.14 times 10.5. All right. 5 times 4 is 20, right? 0 leave 2. 5 times 1 is 5 plus 2, 7. 5 times 3 is 15. Okay, 0 times 4, 0. 0 times 1, 0. 0 times 3, 0. 1 times 4 is 4. 1 times 1 is 1. And 1 times 3 is 3. So we add up 0, 7, 5 plus 4, 9, 1 plus 1, 2, and 3. Now, how many places of decimal do we have? 1. After the decimal, we have 1, 2, and 3. So, we count 1, 2, 3. We'll place a decimal here. So, our answer becomes 32.9 centimeter. Our answer is 32.9 centimeter. Let's take another example. Okay. Find the circumference of a circle of radius 1.75 centimeter. Take pi as 22/7. We are looking for the circumference. The circumference C is pi d. Pi is given as 22/7, and d, we aren't actually given d from this, but we have a relationship. D is 2r. 2r. So if d is 2r and r is 1.75 centimeter, it implies that d will be 2 times 1.75. Okay. 2 times 1.75. So we could come over. D becomes 2 times 5. Okay, let's do this. 1.75 times 2. 2 times 5, 10, right? 0 leave 1. 2 times 7, 14 plus 1, 15, right? 5 and leave 1. 2 times 2 times 1, 2 plus 1, 3. All right, we have 2 places of decimal, so we have our points here. So D becomes 3.50 centimeter. So we could go over C is pi d. This becomes 22/7 times 3.50. 22/7 times 3.50. So we need to calculate this together. 22 times 3.50. Okay. Zero times 2 is 0. 0 times 2 is 0. 5 times 2 is 10, right? 0 and leave 1. 5 times 2 is 10 plus 1, 11. Okay. 3 times 2 is 6. And 3 times 2 here is 6. So we add up. 0, 0, 1 plus 6, 7, and 1 plus 6, 7. So we need to take the decimal place here. Okay. 1, 2. So we have 77.00 divided by 7. By the time we divide that, 77 divided by 7, 1, 1, we are left with 11. So the answer becomes 11 centimeter. All right. Try this. Find the circumference of a circle whose radius is 7 centimeter. Take pi as 22/7. Calculate the volume of a sphere of radius 4 centimeter. Take pi as 3.14. 3. State the relationship between a sphere and an hemisphere. This brings us to the end of this lesson. Please remember, it's very important for you to attend all the exercises you've been given. It would help you and make you a better person. All right, and now get ready to write the examination online from the comforts of your home. If you have any challenge, you get to us through the WhatsApp number displayed on your screen. I'm so glad you were able to go through this series, Module 1, Module 2, and Module 3. Remember, in this module, we had discussed some series of topics like areas of shapes, rectangles, squares, triangles, and other figures. We talked about plane figures, Pythagoras rule, two-dimensional shapes, angles and their types. We talked about polygons, properties of three-dimensional shapes. We talked about height and distance, scale drawing, plane shapes, parallel and perpendicular lines, properties of triangles, trapeziums, parallelograms, and rhombus. We also discussed construction of 2- and 3-dimensional shapes using cardboard, paper, and other materials. We try to identify and count the edges, the faces, and the vertices. And today we've discussed the structure of the earth, which is spherical. We talked about the properties of a circle, and then we're able to calculate the circumference of circles. So I'm so glad you were able to go through this module. I wish you all the best. Thank you and bye-bye.